All right, so thank you everyone for coming to the last session. I hope you had a great time so far. Yeah? Yeah, perfect. That's the right spirit. I'm sure the people from JNation will be very happy to hear that. Speaking of the people from JNation, I want to quickly, before I start, give a huge thank you to all of the organizers, to the volunteers. They have been sacrificing their free time, some of them even unpaid, to make this conference as awesome as it is for you. I think that deserves a big round of applause from us. And you can see, by the way, just like the conference is kind of sunsetting, at least the first day of it, this is here a picture I took yesterday at the speakers' dinner. We had a beautiful sunset. I hope you have seen it too. And else, maybe, I hope it will be the same for you today. All right, so my talk is called "My Code is Faster Than Yours, Let Me Prove It to You." You will hear in a moment why this talk came up to be with that title. But first, let me introduce myself. So my name is François Martin, and I'm a senior full-stack software engineer working at Karakun. We develop software for customers, and we also do consulting. We have offices in Dortmund, Germany, and also in Basel, Switzerland. I'm also from Switzerland, by the way, and I brought some Swiss chocolate. So if you want some, come after the talk to me, and I'll give you some. Oh, I heard some good words. That's nice, thank you. And I'm also an active member of the Swiss Testing Board, which is a member board of the ISTQB, which drives forward certifications in software testing. And there I'm a co-author of 2 syllabi. One of them is one that was just released, which is the test analyst, and one of them is the security test analyst, which is still in progress. All right, then. So we are going to start with the performance of regular expressions. So I was in a project and I've stumbled across this code. You can see this code here. I hope you can all read it. Maybe last row, give me a quick thumbs up. Okay, looks good, thank you. So you can see this code here, and I'm kind of wondering if you got this code submitted in a code review, who of you would merge this? Raise your hand. Okay, so maybe 1 or 2 hands, not so sure. So you might be on the right track here. So maybe also let me ask you, who of you used regex before? Okay, so that's most of you. That's what I kind of expected. And who of you likes using regex? Okay, that's not as many, but still quite a lot. And let's see, so who of you likes also writing regex? Okay, that's almost nobody. I kind of expected that. To cite a good friend of mine, Merit, she once said, what is the plural of regex? It's regrets. Yeah, so let me show you. I was stumbling across this code because actually it was reported by a Sonar cube finding, and we had to fix it because it was marked as a blocker. And the problem was here actually that this was vulnerable to a RDoS attack. So you can see, by the way, here, if we have this example input, what this code does is it then replaces it with this expected output. And as I mentioned, this code had a RDoS vulnerability. So let me also see quickly, who of you knows what RDoS is? Okay, that's almost nobody. So here again, you can see here, there is like an underline on RDoS. If you scan the QR code on the top right, you can enter email address, and then you will get a personal email from me with the slides. And then you can simply click on this RDoS, and this will lead you to a link where you can read a bit more about it. And the QR code will be there on every slide, so you don't need to hurry. And you can see if you have this exact attack string here that you put in as the input, then this will result in a so-called RDoS, which is similar to a DDoS, which I'm pretty sure most of you are familiar with, which kind of makes the server slow and could really lead in worst cases for the server to crash, which of course we don't want to have. So yeah, I mean, you can see, on the one hand, this code is vulnerable, but it has also another problem. In my opinion, I feel like it was not really something that was also really well readable. I think that's probably like, I don't know, matter of preference. Maybe let me ask you, like, who of you thinks this code is readable? Okay, that's no one of you. I'm really proud of you guys. You're doing well. All right, so, since this method was exposed to customer data, or customers could enter things in here, we had to fix this because this was a security issue, of course. So first, what I did was, there were no unit tests, so I wrote some unit tests to reproduce the behavior, because I was kind of afraid of breaking this, because you never know, there could be some unintended side effects. And then I was able to reproduce the behavior, and I was thinking how I would fix this. So one of them would be to simply get rid of the redos vulnerability, but that is kind of hard to do in a way that you can make sure that you really fixed it definitely. What is always easier is to just rewrite it in procedural code, or just write it without a regex. That's usually the easiest and the most safe option. So what I did was I rewrote this code to be procedural. And how it looked like was like this. So maybe you can see, I don't expect you to be able to read this, by the way. Maybe you are able since the screen is so big, but you can see it is quite a lot of code. And kind of understandably, when I sent this for code review, my colleague said, well, are you sure we can't just keep it as a regex and just change it to a different regex that isn't, susceptible to redos? And I told him first, in my opinion, this code is more readable as well. He disagreed. Well, I mean, here, of course, this is kind of a matter of taste, so this wasn't an argument. So I realized, I said, but this code is also more performant. It's faster than the regex. Regexes are kind of known to be slow. I think they're really good if you are trying to make some replacements that are one-offs. But I think in production code, you always need to consider, is there maybe another thing you can do that is even better, especially if it's like in a case like here where it's security critical. So I kind of told him, it's faster, but he told me, well, I don't really believe you. To me, it seems like this code is slower. Look at how many lines it is. And if you look at the regex implementations, it was just 3 lines. So I kind of had to prove to him that this code was faster. This is kind of where the title of the talk comes from. And I used JMH, which is like a gold standard in Java, as a library that you can use for this. And I also have to say that my goal for you in this talk is that you, by the end of this talk, are able to write your own JMH microbenchmark from scratch. So let's look at the comparison. Here is the benchmark that I made, and you can see on the y-axis, it mentions the replacement character ratio, which is before the pipe sign, and there, one illegal, this kind of means that there is one so-called illegal character, or a character that is being replaced per this many characters. So just to make it simple, the lower the number is, the more illegal characters are in the string. And you can see, if we compare the two approaches, the one with regex, which is the darker gray, you can see that regex, as the bigger number is worse, you can see that regex is a lot slower than the approach with just iteration that I've written to replace it. This kind of surprised me. I knew it would be faster, but not that much faster. And you can see, it's like 4 to 8 times faster. And also what is kind of interesting is that the more replacements you make with regex, it's about 50% slower, which is also not really ideal for security. For security, the idea you wouldn't want to process everything in like constant time to be able to not be susceptible to attacks where, for example, an attacker could guess what is happening behind the scenes. So if you look at the iteration approach, it's only around 20% slower. So, it's not constant, but it's still, not as bad, at least. So, in my opinion, this kind of proves really well why this is superior in terms of how I wrote the code. And this worked. My colleague, he believed me, and I was able to merge the code. So, that was a success. So let's get into microbenchmarking. So before I do that, by the way, let me ask you, who of you writes Java code or knows how to write Java code? Okay, that's almost every one of you. And the ones that didn't raise their hand, who of you knows how to write JavaScript code? Okay, a few hands. So the other ones that didn't raise their hand, there will be one slide on JavaScript, and so the guys that raised their hand with JavaScript, you can feel free to leave after the JavaScript part, because I'm not sure if it's that interesting to you, but of course you can feel free to stay if you want, but it will be heavily focused on Java in this talk, just to kind of set the stage here. And also for the guys that didn't raise their hands, as well, you're free to leave if you feel like it's too Java heavy for you. So just to show you here, microbenchmarking is about measuring the time or the performance of a small to very small building block of real programs. And it says also this can be a common data access pattern, a sequence of operations, or even a single instruction, as you can see a little bit later. And as I mentioned, the state-of-the-art tool that you can use for this in Java is JMH, and also here you have a link to that. So now we come to the JavaScript slide, just to represent JavaScript also a bit here. Since I'm a full-stack software engineer, I sometimes need to do both. So on the one hand, there is a website which is called jsbenchmark.com. By the way, here under this link, you can see an example on how you can, for example, compare the performance of sorting an array of multiple different of integers with multiple different approaches. So here you can figure out which approach was the fastest. Then there are more tools like perf.link. And again, you have here a microbenchmark for regexes, for example, because I was kind of curious, is it also the same in JavaScript? And there's another one which is called benchmark.js. This is a library in comparison to the other two links. The other two links, you can simply go to the page and then run it in your browser. The one with benchmark.js is not as easy to run, and also the library is kind of old. It's from 2016, and it seems to be unmaintained. But yeah, it still seems to be working well. So, and to my knowledge, there is not really an alternative for any statistically, if you want any statistically significant results, other than using benchmark.js, unfortunately. I think the first two options are kind of fine if you want to just get an idea how the performance is. But if you really want significant results, you should use benchmark.js for that. So now, when should you use microbenchmarking? So what is important to keep in mind is that microbenchmarking is best suited if you are comparing the performance of different implementations and also under controlled conditions. So compared to profiling, which maybe some of you may also be familiar with, profiling is something you use if you want to understand and improve the performance of applications in real-world scenarios in comparison to controlled conditions, and in this case, use profiling. Basically, if you're not in a case like I was, where, for example, you have an application that is slow, first you will use profiling to find out where are your bottlenecks in your application. And once you figured out where the bottlenecks are, you're then using microbenchmarking to improve this bottleneck to be able to get rid of it, essentially. So yeah, so let's already dive deep into it. So I'm going to walk you through step by step on how we can set benchmarking up, microbenchmarking with JMH. So there is a readme.md in the JMH repository, which I really recommend you to read. It's really well written, and it contains a lot of information you have to pay attention to. I'm going to show you the most common pitfalls you can walk into, but maybe it doesn't hurt to still, if you have some moments, to read through it. And it recommends you to run this following command. And you see it's kind of standardized with Maven. You could, in theory, also run it with Gradle, but they discourage doing that because it's not like 100% validated or something like that. At least, I would really recommend you to stick to what the README says you should do in terms of what is the best practice, because if you don't, then you could have some inaccuracies. And what this does is it creates a folder with the same name as the artifact ID that you can see here. So then you open the folder in your IDE, And then we already have like a basic example of JMH setup. And then what you need to ask yourself next is, what do you want to compare? So maybe just like you learned in science class in school, it makes sense to think about what you want to benchmark. So I'm going to walk you through maybe a little bit of a simpler example here that I prepared here. So to whom of you does this seem familiar to, this kind of string that you see here? Maybe not with this text, but with these special characters and so on. Okay, I see a few of you. So this is kind of an encoded text, and specifically an HTML encoded text. And let's say that, for example, when we decode this is how it looks like. And we notice that in application with profiling, this is a bottleneck because this is being run very often. And we notice this is causing us issues because it's too slow. So maybe you could compare what kind of ways are there to do this. And so this is, for example, now my goal. I want to find out which of the different implementations that are available to solve this issue is the fastest. So there are many libraries that are available. Probably there are even more than those that I listed here, but just here for reference. Here you can see there are different libraries that you can use, so like Apache Commons Text, JSoup, Unbiscape, and even Spring has one. And I recently had actually a case where in production we had a bottleneck here and what was kind of slow. We had to do a lot of replacements this way, and this is why I made this comparison in the first place. So then we need to think about what is our expected outcome and why do we expect this outcome to be this way before we run the test. Just like I mentioned, just as in science class, you first set up the hypothesis and then you try to prove it or disprove it in a way. So what I'm wondering here is, which one is the fastest when decoding lots of different strings? It really makes sense to make this as specific as you can, because each use case is differently, of course. And then optional could also be, but maybe recommended could also be that you think about what is the expected outcome and why is this outcome like that. And here you need to keep in mind, I'm speaking about fastest, but fastest always depends on the context. So I already alluded to it a bit earlier, but it's important to know the context in which your code is used to be able to perform an accurate microbenchmark. And microbenchmark should replicate the production conditions as closely as possible. So if, for example, in your production code, you simply have, one case where you run it through one string, then that's, of course, totally different than if you had an endpoint that processes hundreds of different strings, of course. And ideally, it should also use data that you observed in production, if that's possible, if you don't have some restrictions that prevent you from doing that. And even maybe you're able to benchmark in production hardware with the same JRE, but still, don't let this discourage you. If you run the test on your own machine, this is still better than doing no test at all. So, it's ideal, but of course, it's still fine if you do it on your machine. And depending on the data that you use, the performance can also vary significantly. A good example of this, in my opinion, is quicksort. So maybe you remember from your CS classes that quicksort operates generally with a complexity of O(n) log n, which makes it some of the fastest sorting algorithms for most of the cases. But then if you have sorted data with just the regular algorithm that you have for quicksort, it usually degrades to O of n squared, which is a lot slower, which means that in this case, if you have lots of data that is very close to being sorted already, maybe some other sorting algorithm could be better. So this kind of shows why it matters, what kind of data you use for testing. Because if in your production application you only have sorted data or almost sorted data and just one string is out of place, it may be faster to take a different algorithm, but if you were testing with just random data, then of course, randomly ordered, then you may miss the aspect that the performance isn't as good as you think. So, as I mentioned, this could lead you to kind of a wrong decision when you run the microbenchmark, so definitely make sure to pay attention to this. So the command that we have from step 1, it generates like a basic so-called mybenchmark.java file. You can see it looks like this. And each comparison that you want to make, you want to put in its own @benchmark. So you may think now, okay, so that sounds really easy. So what I'll do is I'll simply put here the method that I want to execute, and then, this runs my benchmark, right? Well, unfortunately, it's not quite as easy. So the Java compiler is, unfortunately in this case, too smart, and it removes actually lines of code because they're redundant. It is a static method that gets called, and it does nothing other than just simply returning a string, which is not used here. So it knows it could simply, not call this method, and the code would be doing the same. So we need to pay attention that this doesn't happen. And this is, by the way, dead code elimination, and you can find a link here in the JNation repository. There are a lot of different files explaining different gotchas you could run into. It also definitely doesn't hurt. I'm going to show you the most critical ones in this talk, but of course don't have time to show all of them. So if this really gives you a good starting point to make a benchmark that will give you good results. But if you want to be the most accurate you can, of course you should look through all of the samples and try them out if this is really critical. So what you can do instead is, if you're only performing one operation, you can simply return the result instead. So you see we change void to string, and then we simply return the result. And this already makes Java know, oh, okay, this is returned, so I cannot simply just get rid of this because it is needed. And actually, that code elimination and other things is kind of a reason why microbenchmarking in JavaScript is also a bit easier than in Java, because in JavaScript you don't have as many optimizations that are being performed. But in Java we kind of have to struggle a bit with this. But yeah, the results are kind of worth it, in my opinion. So what you need to do if you want to kind of return multiple results or need to do multiple things, then you can use a so-called black hole, which is as you can see here, you simply define it as a parameter of the method, and then you can simply use it and call bh.consume, and then you can pass in what you want to do. And you can see here, for example, I have a for loop, because as I mentioned, I have the case that I want to test if when using lots of different data, if it is a good performance or not just by one run. So I'm using a for loop here to run through multiple different strings, to see how the performance is when decoding it or unescaping it, as it is in this case. And by calling bh.consume, we make sure that Java doesn't optimize it away, because if we didn't have this here, again, Java would realize when compiling it, oh, we don't do anything with it, so I'll just get rid of it. Yeah, which is, of course, really nice in production, but in microbenchmarking, it's a bit of a hurdle, of course. So yeah, by the way, make sure you only use loops in benchmarks if you use them in your production context as well. Because the just-in-time compilation of Java is very good at optimizing loops, you only want to include loops if this is the case in your production environment, because if you do this to just test different test data, then this will result also in inaccuracies again. But of course, if in your production application you're using loops, then you want to use loops in the microbenchmark as well for it to be the most accurate, because, of course, the JIT will do some optimizations, but since you're doing them in production as well, this is the way that you should go. Again, keep it as close as possible to your production use case here. So also, do not use loops to test different data. If you want to test different data, you can look at the link behind this test different data, and again, scan the QR code to get the slides, and then you can find out exactly how you could do this. All right, so then let's think about microbenchmarks. They are usually executed in multiple iterations of measurements. So you usually do this because you get better accuracy, and also you can determine better the range of the error So by running it multiple times, you can see like how much do the individual results vary from one another, and you can see if the result is more or less accurate or not. Because if you just measure once, you never know if maybe on the second run, if maybe then suddenly the performance is much worse or much better, and then maybe there's some optimization going on that you need to get rid of, or maybe something you didn't think about that Java kind of gets rid of. All right, so for example, let's say you use the state like this. Then the JVM could perform something which is called constant folding. So this means that even if you use a black hole here, Java could reuse the same result in each iteration without executing the code again, which again would lead to incorrect measurements. If the JVM simply looks at the, in each iteration, the function is just called with the same object reference. So the JVM knows that it can simply assume that it can replace further invocations with the result that it obtained from the first execution, and then it can simply use that in every following execution. So this is what constant folding does. Which again, if it's in your, if it's like that in your production application, it's totally fine. But usually it probably isn't, and then you have to take care of this. So don't use an approach like this. What you should do instead is you should use the add_state annotation. So you can see we can simply specify, for example here, add_state scope.thread, and this way we tell it to scope the state per thread that it executes for the microbenchmark, and this way we can kind of escape this issue. And again, if you want to find out more about the different add_state annotations, I set it here to scope.thread, but in some other cases you might need to use different annotations. You can look it up under the link that you can find here. All right, then usually it makes sense to add some annotations that would recommend you to. So again, you can link on the benchmark modes if you're curious to see them all. I just put the most relevant here, or the most that kind of can get you started already with some basic knowledge. So here we have mode throughput. So this is a measure of how many executions it can perform within a given time unit. So this is, by the way, the only mode where when you get the score at the end, if the score is higher, then this means that the result is better. Every of the other benchmark modes, usually when it's lower, it means that it is better. Just keep this in mind if you're using this. And then there's, for example, the mode average time, which on the other hand, compared to throughput, just measures the average time it takes to execute it. And again, here the lower score is better. So yeah, which one you use depends on what you want to know. Are you more curious about how many times you can call the method within a given time unit, or like how long it takes? But both are somewhat equivalent. It especially makes sense to use throughput if your numbers are very small. Like, if you are comparing nanoseconds at average time, it may be better to use throughput. But again, just use what you feel more comfortable with and what makes more sense for your use case. So then we have some other annotations that I recommend you to use as a starting point. You can see here we have warm-up, measurement, and fork. So just, these are some things we specified to make sure that the JVM executes the code in a way that is most accurate to in your production use case. You can tweak them a little bit to, if something doesn't, isn't as you expected. Like, for example, if the if the error is too high, then you can simply increase the amount of iterations. By the way, also if you increase the number of iterations, this makes the benchmark take longer. So also just keep this in mind. Your benchmark will take longer to execute. But of course, if the error that you see at the end is too high, then you definitely want this. And then if you have long-running operations like I/O or complex computations, it also makes sense to increase the time. Here, the time, not the amount of iteration, to make sure that you can cover this as well. So then for the most accurate results, and again, here, it's better if you run any kind of microbenchmark than, keeping all of these things that I'm telling you now in mind. These are just to make your results even better. So, these are kind of if you want optional. It really depends, of course, on the error that you get and how, let's say, close the different results that you're getting are. So one of them is you can or should turn off dynamic CPU frequency scaling in your BIOS. So it often is called something like power saving or turbo boost. So if you have dynamic CPU frequency scaling turned on, this means that your processor in your PC, depending on the workload that you're running, runs either slower or faster. And of course, you can imagine, since the microbenchmark is simply running some bursts, for example, and this could be, for example, not as accurate as when running it on your production hardware, because maybe your CPU is running at a slower frequency first, and then suddenly it notices, oh, there's a load, so it spikes it up. But still, the first part where it didn't notice it will be run a bit slower. So there you could have some error that gets introduced. And also, it makes sense to restart your computer just to make sure you don't have any background processes running on your PC that could also, again, maybe result in you not having enough resources to run the benchmark. And also try to close all of the other applications, background processes, your browser ID, and so on. Ideally, you just want to have a terminal where you run the microbenchmark. And of course, don't do it while running a talk, of course. And then we can run the following commands in our terminal window. So you can either run even clean verify, or you can run this command, and then you run this command afterwards. And then we get our results printed. And they could look something like this. And they get printed at the end. You can have a quick look at them. And you see, we get some scores here, but it's a bit difficult to tell. So I usually like to turn these data into some visualizations. So if you turn them into a visualization, that's how it looks like. And you can see, it's not mandatory to do a visualization, but you see that it, at least to me, I'm kind of a visual person. To me, this really helps to see how the performance is. So you can see that the crazy thing about these results are that Spring is 27 times faster than JSoup. Well, this actually doesn't specifically mean that Spring is better. It could be that, of course, JSoup handles just more edge cases that Spring doesn't, which again proves why it's important to pay attention that you use data that is as close as to production as possible. Because it could, of course, be that it is just the case that you have an edge case which, for example, you didn't cover because you didn't have, test data that was accurate enough. And so this is definitely something you should pay attention to. And of course, especially in this case, since those implementations are open source, you can always go ahead and look at the implementations and see for yourself, are there differences in the way that they are implemented? Does one cover edge cases and one doesn't? But also, maybe you don't have that many edge cases, and maybe Spring is good enough for your application. So again, that's why it's important to make sure you use the same data as you use in production to see if it's right for your use case. All right, and then when it comes to the interpretation of the results, this is an advice that gets printed at the end of each JMH run. It mentions something like, to gain reusable insights, you need to follow up on why the numbers are the way they are. Again, this points out, just like I mentioned earlier, it could be that maybe Spring is just a lot faster because it has some edge cases that are not covered. And also another important point I want to highlight here is it says, ask for reviews from the domain experts. Do not assume the numbers tell you what you want them to tell. Especially as you start out, it can be really useful to just ask some other people, what they think about your microbenchmark, if they feel like it is accurate. The Java community is really helpful here, so feel free to reach out to some of the people. There are quite a lot of people involved with JMH, and I can tell you there are more than you would think that would be happy to review your benchmark for you to help you out here. All right, and this doesn't mean that it will perform the best in every scenario. It will just tell you that in this specific context that you tested under these very controlled conditions, that your code will be, maybe faster or slower. Just keep this in mind when interpreting the results. It doesn't mean that, for example, using Spring will be the best for every kind of test data that you have. And also, it definitely makes sense that you verify to ensure the functions that you benchmark work correctly. Like I mentioned, maybe there are some edge cases that are not covered with Spring. And to be able to do that, just make sure you write unit tests to verify if it works the way you expect it to with all of the different implementations as well. And then also keep in mind the microbenchmarking results will be different depending on the hardware that you are using and also some other factors. So just keep this in mind when you are implementing it. So for example, don't run a microbenchmark on your machine and then simply run a microbenchmark on your friend's machine and assume that those results are comparable. So make sure you run them on your same hardware to be able to make them comparable. Also, I recommend you to, again, as I mentioned briefly in the beginning, to work through the samples that are provided by JNation. Again, you have here a link that already brings you to the page where you get all of the samples, so you can work through them in case you're interested. As I mentioned, the examples that I've shown you here are the most crucial things you need to consider when doing a microbenchmark. And I hope I was able to convince you that it isn't as hard as you maybe have thought. Of course, as with anything new you learn, there is like a learning curve. But just to make your life a little bit easier, what I did for you is, again, if you scan the QR code, you will not only get the slides, but I will also send you a link to a template repository on GitHub, where you can simply use that template repository to clone it as your own repository, and then you just have to use that as a basis to implement your microbenchmark. You don't need to run the Maven command, and you also get some of the annotations I mentioned that I recommend that are already pre-done for you, so really it makes it a lot faster for you to implement a new microbenchmark. So of course, feel free to use that to make it even easier. And if you're curious to learn a bit more, I have quite a lot of links. Don't be shocked that most of them are kind of pointing to the similar place, but just, are more nested links. Really, if you want to become an expert on this topic, these are some of the resources I would recommend you to look through. So, I'm already at the end of my presentation. I hope you enjoyed it. Thank you so much. So we still have some time for questions. Are there any questions? We can pass around the microphone. Just raise your hand. All right, I see a hand there. Also, while he's passing the microphone around, I also brought some stickers and, again, Swiss chocolate, so feel free to approach me after the talk. Also, if you have some other questions we cannot cover until the end of the talk. All right, so is the microphone already? Oh, no, it's still on the way. Okay.
Hello. In the context that we work with cloud providers and we have different machines, would you consider running the microbenchmark with different machines on the cloud to see how the code behaves?
I didn't understand the first part of the question with the context. Can you maybe repeat that part?
So on the cloud, we have different type of machines available nowadays, like we have on our local computers. Would the tests show us better results if we run them on the cloud with different machines and same memory, CPU specifications?
Yeah, thank you. That's a really great question. So I can tell you here, it kind of depends. So this is like the consulting answer, of course. So especially, for example, your cloud machines are running on different architectures than your architecture of your, let's say, for example, you have a AMD 64 processor in the cloud, and on your machine you're running, for example, on ARM 64. And it definitely could make sense to try it there. But again, I think I would expect in most cases at least, unless there are some very specific things that are different, that it will be similar. I would recommend you, if it's easily possible, try it on the cloud machines, because of course this will give you a much more accurate result anyways. But you could also try it locally and see how the results are. If, for example, as in my example with the regex, if it is the case that it is that one of them is like 4 to 8 times faster, I wouldn't expect in most situations for this difference to be let's say, in a way that the other one would be faster and not one of them. Usually it will just be that maybe the results are closer together, so maybe one of them is not as fast as the other, but it still gives you an indication of, is this approach faster than the other? So, in summary, if you can run it on the target hardware would be better, but if you can't be bothered to do it, running it on your machine is fine enough as well. I hope I was able to answer your question with that.
Okay, thank you.
Yeah, you're welcome. Any other questions? I see some hands, so yeah. Or not anymore, maybe it was just a yawning. I don't know, does anyone of you have any more questions? Okay, I see one up there. On the top, yeah. I'm not sure, maybe you can raise your hand again, or did you not want to raise your hand? Great, just so that the helpers know where you are, yeah.
You had shown some cases where the optimization interfered on the results. How to identify these cases, except the ones that you had shown?
So what was the question? How do I what?
Do you identify that the optimization interfered on the results?
So somehow always the word after do you, it kind of is bad in terms of the acoustics. I don't know, can you try, maybe speak a bit?
Okay. As the GVM do optimization on the code, how can I kept?
How can you kept? Did you say kept? So how you can see if it is optimized or better? So the question is, for example, let me go back to one of the other slides. I hope I understood it this time. I think it was the one where, no, I think it was a bit farther ahead. Yes, here. I think in this example here, for example, how I would find out that here it would eliminate the code if I didn't return string here. Was this your question? Yes, all right, perfect. Thank you so much for coming here. So you can look at the bytecode, which will tell you very precisely what the VM does when it compiled the code. This is the, let's say, the surest way to do this, but of course, bytecode isn't as easy to read as regular code. So you need to be a bit proficient there if you want to really be sure, to the most exact degree. But I can tell you, if you walk through all of the samples that you have seen in the JMH repository, usually this gives you a pretty good idea of what you need to avoid to make sure that it won't be affected. And usually this should be good enough. But of course, if you want to be very sure, it's always the best if you look at the bytecode. But I know it is probably something most of you, maybe not willing to go through this extent. But yeah, thanks. Very good question. I hope that answered the question for you. All right, thank you so much. Are there any more questions? I left a lot of time for questions, so you have some time. Let's see, raise your hand. Okay. I don't see any hands. Okay, good. So I would say, then I'll let you go to the after party a bit earlier. Thank you so much for being here. And again, I'm available afterwards. Just feel free to come here if you had a question that I didn't see. And again, thank you so much for coming here.